In this video, we'll learn how to express inverse functions in their simplest form. Let's learn this using an example. Tan inverse root of 1 plus x square minus 1 divided by x. This is the constraint for x can't be 0. So we need to simplify this expression. Now pause the video, figure out how we can simplify this. Okay, let's do this together. Now what substitution should we use for x so that we get a simpler version of this? Let's look at it. We have 1 plus x square inside the square root. We can replace x with tan of theta. Think about it. If x is tan theta, 1 plus tan square becomes secant square theta. And this is a perfect square and we can get rid of this square root sign. Root of 1 plus x square, that becomes secant theta. Now we have root of 1 plus x square minus 1 in the numerator. This becomes secant theta is 1 by cos theta. So 1 by cos theta minus 1, that's 1 minus cos theta by cos theta. The denominator is x. So this becomes this divided by x is tan theta, that's sin theta by cos theta. So we can cancel cos theta. This becomes 1 minus cos theta by sin theta. Now we have to take tan inverse of this. So we want to represent this in terms of tan. How should we do this? This is 1 minus cos theta. We can use an identity. We can say that this is equal to 2 sine square theta by 2. And similarly, we can say that the denominator is 2 sine theta by 2 cos theta by 2. We can cancel 2 here and 1 sine theta by 2 cancels out. This becomes sine theta by 2 divided by cos theta by 2, which is tan theta by 2. And this is what we need. We need a tan of an angle so that we can cancel tan inverse. So tan inverse of this becomes tan inverse of tan of theta by 2, which means it becomes theta by 2. And what's theta? Theta is tan inverse of x. So this becomes half of tan inverse x. So we have simplified this expression. This is same as half of tan inverse x. Let's try one more. Tan inverse root of 1 minus cos x by 1 plus cos x. Pause the video. Figure out what identity can we use here. Okay, let's do this together. 1 minus cos x by 1 plus cos x. We want this to be a perfect square. This can be written as 2 sine square x by 2 by 2 cos square x by 2. 2 can cancel out. This becomes tan square x by 2. So the root cancels out and we get it which works for us. Root of this is equal to tan of x by 2, which means tan inverse of this is equal to just x by 2. So all of this is equal to x by 2, provided x is within this constraint 0 to pi. Let's solve one more. Tan inverse cos x minus sin x by cos x plus sin x. Simplify this and the range for x is this. Pause the video. Okay, so let's do this together. Cos x minus sin x by cos x plus sin x. We want this in terms of tan so that tan inverse and tan can talk to each other. How can we write this in terms of tan? Let's divide both numerator and denominator by cos. This is 1 minus tan x by 1 plus tan x. Now this can be written as tan pi by 4 minus tan x by 1 plus tan pi by 4 into tan x. That's tan pi by 4 minus x. Tan of difference of these two. Now we can apply tan inverse. Tan inverse of this is equal to tan inverse of tan of this. That's pi by 4 minus x. So this thing is actually equal to pi by 4 minus x. Let's simplify a few more expressions. Tan inverse x by root of a square minus x square. Here mod x is less than a. Pause the video. Figure out what substitution works here. Okay. So if you look at the denominator, we have root of a square minus x square. If x is a sine theta, this becomes, we can take a square common, 1 minus sine square theta, that's cos square theta. And root of that becomes cos theta. Numerator has sine, denominator has cos. Conveniently, we can get tan. So x is a sine theta. This becomes a sine theta divided by root of a square minus a square sine square theta. A square common. This is a sine theta divided by a cos of theta. 1 minus sine square is cos square. Taking the root gives us cos theta. Cancelling a out, this becomes tan of theta. So this is equal to tan inverse of this is equal to tan inverse of tan theta. That's just theta. And what's theta here? X by a is sine theta. So theta is equal to sine inverse x by a. So this can be simplified to sine inverse x by a. Last problem. Tan inverse 3a square x minus x cube divided by a cube minus 3ax square. The range for x is this. So what substitution works here? Pause the video, think about it. Alright, so this is the triple angle identity for tan 3x minus x cube by 1 minus 3x square. If x is tan theta, this becomes tan 3 theta. But we also have a in the picture. So let's assume that x is equal to a tan theta. So this becomes 3a square x minus x cube divided by a cube minus 3x square. This is equal to 3a square times a tan theta minus a tan theta cube divided by a cube minus 3a times a tan theta squared. In the numerator we have a cube. Denominator also has a cube and a cube. So let's take a cube common from both numerator and denominator. This becomes a cube by a cube. What's left? 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. And this thing is tan of 3 theta. A cube and a cube cancel out. This becomes tan 3 theta. Now we can take tan inverse. This becomes 3 theta. And what's 3 theta? Tan theta is x by a. So theta is tan inverse x by a. So this becomes 3 times tan inverse x by a.